for the new day. And as we are ending the month, pray that the Lord will end well with us.
Amen.
As we are started, it's ending with us with some showers of blessings for tonight.
Amen.
Last night, we saw a lot of rainfall.
Sure.
If all of you are surviving at your various places, no flooding issue recorded at your dwellings. Okay, so for those of you who are on, kindly inform your colleagues to join so that we can start.
Okay, sir.
I hope nobody has experienced a flood at his or her end.
Yes, please.
Okay. So let them join so that we can conclude what we started last time. We'll conclude on the network layers. We were able to discuss the OSI model and then the TCP IP. So we'll conclude on it today by considering the IP addressing. As we started, we couldn't finish. So we'll finish that and then we'll proceed with our other aspects that we left. That's the signaling aspect. So those of you who are on, kindly pass the message to your colleagues. We are live. They should join so that we continue. Meanwhile, those of you here, if you have any question or concern with regards to last week's lecture, you can put it across. You can put it in the chat, or you can also raise it, and I'll address them as we wait for your colleagues to join. We'll give them 2 minutes to join, and then we'll start. Any concern from last week's lecture?
So, sir, please,
Hello, can you hear me?
yes, please.
Okay, all right.
Yes,
So
sir.
I think our time is up, so we can start. Sorry, when it rains in Ghana, our network becomes a challenge. So there was a slight break at my end. So those who are there, as I said earlier, you are all welcome once again for today's lecture. We thank God for everybody's life. And those who have received rains, I believe you are all safe at your respective areas. If you are safe, And we thank God. Those who have received challenges, we pray that the Lord Himself will make provision for you. So let's continue from where we ended last week. On our face-to-face meeting, we discussed about the layers in data communication and networking. So we consider the two famous layers that are indispensable in networking and data communication. So we look at IP and then also OSI model. So we started with the layered architecture of network communication. So with the data communication, we identify that the major concern our data communication is about how data move from one place to another. So we look at the layers divided into three main parts. We have the lower layer, which take care of the physical connectivity, including the network. And we have the middle layer, which isolates the lower layer and ensure for end-to-end delivery of packets. Then we also look at the upper layers. And the upper layers, we said they are layers that are closer to the users, and they deal mostly with the programming. So the layers have been categorized into this, and that's what we discuss. Then later, we move on to OSI. We said the OSI model is divided into 7 layers. We start from upper layers, we contain from application to physical. Then we look at the functions of the various layers and the protocols that operate on each of the layers, and their significance in data transmission or data communication and networking. Then we further continue with the TCP/IP, which we said it is also known as TCP/IP suite, and it is called suite because it comprises with a number of protocols. You can also refer to it as TCP/IP stack because of the number of number of protocols that are involved over there. And the main purpose of the TCP/IP is to enhance our communication. So we realize that that one has also been divided into 4 layers, where the first 3 layers are the upper layers are combined to form 1 layer, and then the middle layer has been maintained, and the network layer in the OSI has been replaced with internet or intercommunication network, that is internet layer. And finally, the last 2 layers at the lower part has also been combined to form network layer. So basically, these were the things we discussed. We also look at the comparison of TCP/IP and then OSI model, and we compare the two with the respective protocols that operate in each of them. And we're left with TCP/IP addressing, which we couldn't do before the time. So today we'll continue from here. So before we start, if you have any question or concern with the previous lecture, I'm still giving you the option to ask for redress before we go ahead with today. If no question, then I will encourage you to write down the objective for today, then we'll proceed. Any question, any concern, any contribution from the previous lecture? I think now the house is getting to form a co. We are still less than 75% though. Any question from your end?
So before you begin, I want to ask, with our practical that we'll be doing, can you go over the tools that we'll be using for it?
Can you please raise your voice a bit? I hardly hear you. Can you repeat it, please? The one who had the concern.
So I was asking that
Mhm.
with regards to the practicals, the tools
Yes.
that we'll be using, please can you go over again so that those who were not able to come to the face to face, they will be aware of it.
Okay. But did you communicate some to them? Which one did you remember communicating with them? Course rep. All right. So as I said, for our next face-to-face meeting, we'll have two major practicals. The first one is going to be our physical layer, which will be doing termination of our cables. And the second one will look at how to do IP addressing. This is the theoretical aspect I'll take you through today. Logical connectivity. We'll do logical connectivity and testing. So we'll learn how to assign IP address, look at the various methods involved in IP addressing, and how we can test uh, logical connectivity of devices after we are done with the first one. So we'll need some items, which I said we may have to divide ourselves into groups, and each group should have members of three. And these members of three in the group should be able to acquire some of the basic accessories and tools that you need for the practicals. Even though as institution, we'll make some of them available for practical demonstration, but to not be enough to cater for all of you. So to be at the safer side and to make the class very um, interesting and then also practically oriented, you need to help by providing for your own groups IJ45. So first thing we need is IJ45, which is an accessory that we need for the connectivity. If anybody here can even supply or volunteer to supply for the class, we'll be glad to receive and then thank the person so much for God's blessing upon his or her life. I believe our brothers have just finished their celebration of the fasting. So Allah will bless whoever will supply that. And next week, Christians will also have our Easter festivity. Anybody who supplied will also receive the abundant blessings. So IJ45, each group, we are supposed to provide for ourselves, the one that will help to be able to demonstrate. Two, you need the tools that we need for the crimping. So we have what we call crimping tool. Crimping tool. So each group should at least have one. If all of you can acquire it, that will be fine. Because once we are doing this course, it is our hope that you should be able to go out there and start demonstrating the practical skills in the industry. So it is a requirement that at least every one of you should get a crimping tool for practical purpose. So if you cannot afford as individual, you can buy as a group for the purpose of our class. Each group should come with IJ45 and a crimping tool. Then the next thing we also require is we will need a media tester. Media tester. We will make provision for one for the general class. But as groups, you need media tester so that if you are doing your own individual cables, you can test them. The purpose of the media tester is to test the cables after you are finished preparing them or terminating them. And it will be a working tool. So as you get it, it is for you. It's not for the school. So it will help you wherever you go. So I will encourage you get that one. And the next thing is you need a cable, a UTP cable. You can buy the UTP or STP. So course reps, you can organize, I think if the whole class get one box, it can cater for all of you. That one, I would advise you get it as a group. But if you want to still go by individual, then that's a choice that you can make. But I would advise that the whole class can organize for one. But again, if there is professionals around who would like to supply to the class to find, I will make some available though, but I don't know how how best I'll be able to provide for the entire group. So at least the class, if you can get one box of either UTP or STP, that will be fine. But the most important one is getting the cable. There are different types of cables, but the UTP is the easiest one that we can all use for the purpose of our studies. The data come to further level, we'll be talking about the switches and then the routers. But for now,
Sir, sir,
we'll
good
make provision
morning.
on
Sorry
behalf of the institution.
for
Yes,
chipping in.
we are in the afternoon.
Sorry, sir. Good afternoon.
Hello.
Hello, sir. Please, can you hear
Yes.
me?
Yes, I can hear you now.
Okay, so I was suggesting the RJ45, like how many pieces will we need? Because I think maybe I
Mustafa,
can
your
provide
voice
like
is not
100
coming.
or
Mustafa, which one? Which are providing?
the RJ45 and the cables. And then I have the tester as well, but I don't have the energizer battery.
The battery. All right,
Yes.
so how many testers are you providing and how many pieces of RJ45 and then what
The
length of
test
cable are you providing?
The tester, I have one, and then the RJ45, I can give about 70 to 100 pieces. And
That's one pack.
then,
A pack is
yeah,
a pack contain 100 pieces.
says, yeah, either 100 or 200.
And the two should be fine because each group is going to prepare two sets of cables, which means that each group will need a minimum of 4 RJ45. So, Coswebs, if you are 100 students, then it means that you need 400 pieces minimum. So, if you are supplying this one, Mustafa, then that's good. Thank you very much. We'll take note of it. Whatever I provide, the rest will supplement. Thank you very much. Cosweb, get his contacts and remind him towards the promise he made. And the Lord himself will open heavens unto you and your descendants. This is your offer that you have made. May God open more doors for you. Those who want to tap into it, you can say amen to that. Are you there, Mustafa? Thank you very much. So the rest, please, state chats are open. That will be great. So anybody else, whatever you can offer us, that will be fine. The tester, one will not be enough for the class. So as much as possible, we need more of the testers to facilitate our studies. But we accept this with a great thanks. Thank you very much, Mustafa. Okay, so for now, I will also give you software that will be used for our simulation of some of the practical sessions. And I've already charged you to go and register for NETA card. So Cisco Packet Tracer is something that you will need. If you have successfully completed the course, you will get an ID that will allow you to use the Cisco Packet Tracer for every professional use. But if you have not, I will make provision for you. I'll share that one also when you come. Or those of you can download it also, you can download and install. We'll use that one for demonstration of how we can carry out a network setup, either in the group, client-server architecture, and a peer-to-peer architecture demonstration. So that will also be made available. So those are the things that I mentioned, the switches and the routers. We may need some, especially the non-managed one for now. But the managed ones, I can make 2 available for the class. And those of you who also can get non-managed one or manage, you can also bring some along. So after we are done with the cabling, we'll learn how to set up work group using the cables and the switches. So that's the two major practicals I want us to do before we move on. And your end of semester also, you'll be given a project work assignment. I'm yet to settle down and work on it. Things are delayed because of my up and down, but for now, I think my pressure is coming down. So from next week, I'll begin to send you some of the assignments and the project work that we'll be working on. All right, thank you. Any other having okay. Cause all items you need. Thank you for the reminder. Okay, if no further
Hello, sir.
concern, then let's continue. Yes,
Good afternoon, sir.
afternoon. So
Please, I
also
was
answer.
yes, sir. I was following the list of items you said we should get, but I got lost. Could you kindly go over it once more, please? Aside the cable.
RJ45, crimping tool, media tester, and then the two-step pair cable. These are simple ones that you need for now. You may need a switch, and then further later on to, if we have the chance, we'll need a wireless device. But the wireless device and the switches, that will be the third podcast. So I don't know if you'll be able to meet for the third time, but at least for now, the basic ones are required. IJ45, media tester, clipping tool, and then cable. So Foster, are you still saying something? Foster, are you okay?
Yes, please, sir, you can
Okay,
go
so
on.
let's proceed. If no further concern.
Hello, sir.
Yes, sir.
Yes, sir, go ahead.
So I was asking, with the cable preparation, won't we add maybe a knife and a cutter, or
A
we'll get
knife?
that on campus? Yes, please.
No. With the networking, a knife and cutter are not required. The crimping tool will take care of the cutting aspects and then also stripping of the cable. So the crimping tool is a multi-purpose tool. So with our field now, as at now, you may not need a knife and a cutter. If you are going to the industry to go and do the practical implementation where you'll be laying trunking and so on, that's where you may need a knife and a cutter. But because we are doing it in the lab, for now, the knife and the cutter, the crimping tool will take care of those areas. Thank you. Are you fine?
Yes, sir. Yes, sir. Thank you.
Okay.
Hello, sir. Good afternoon.
Yes.
This
Mr.
is
Baja.
Manobaja. Yes,
Yes.
sir.
Are you good?
I'm good, but then, sir, please, about the grouping.
Yes.
Did you say groups of 3 or groups of 5?
Oh, my mind is 3. Or did you convince me to agree on 5?
No, I'm just
Sir, you
asking
said
for
5.
clarity.
In my mind is 3, but if for your ages, if you want to make 5, that's fine. But 3 would have been the best. So I said the option. I like odd numbers. So 3, 5, 7, 9, 13. But above maximum is 5. So minimum is 3. So you can agree. Do you want 5 members or you want 3? With me, I'll prefer 3. But
1, 3.
if you want
Sir, we
to
want five.
5,
Five is
Sir,
okay.
we want 3.
5, some people will not
Oh,
work.
five
Oh.
is okay. We have done the five already, so let's
Sir,
maintain that,
we want
please.
3. We want 3, because
And 5 is done already.
5,
The
some
last
people.
time we
3,
made
3.
it, I said five, so we went by that. So the groups have been created already. So if you are saying three again now, you are giving more work to the course rep. Please, let's maintain the five and go by that.
But I remember I said I started with 3. You don't know whether you have decided to conclude on 5. And when this question came up, I said maximum should be 5. But then my first priority is 3. That's what I said. So you have settled on 5, right?
Yes, please.
In that case, then each group provide 4 cables. If you agree to that.
Hello, sir.
Yes.
So are we going to need a keystone too because of the trunking that you want to do?
The keystone, that is my next target because of the time. We may not be able to do the patch panel with a keystone. So if you do another datacom again, datacom 2, then we can add a keystone and then a patch panel. Yes. I will get
Hello,
it.
sir.
I'm coming. If I want to do those ones, I'm not careful, we'll not be able to finish the remaining aspects.
Yeah.
So let's do the first one first. If looking at the period, the 2 hours, we can't do all those practicals in that 2 hours that day.
Okay.
That's why I want us to focus on the first 2. We do the termination, then we move on to do the connectivity and test.
Yeah, because after this thing, you need to get some small jobs to do.
Exactly. That's why the infrastructure is important. But looking at the time constraint and those patching and then the keystone termination cannot be done. They cannot be done online unless we have face-to-face.
Face-to-face.
So let's look at it. Let's finish the first 2. If you come and then there's time. Some of you are on the field may easily get it, but for the new ones, it will be difficult to speed and then cover all the areas. But we can discuss up to a point. If you do the datacom 2, then at that point we can add a patch panel and then a faceplate to it.
Okay.
And including switching and routing. Yes, next.
It's better again, sir. Please, with the I have a concern with regards to the practicals. Since it will be face to face, and then looking at the turnout for the previous face to face, I believe going by the 3 members will be better because the 5, well, if most of your members are not able to come for the face to face, then it becomes a challenge for you that you'll be able to come. But then if the number is not that many, it's so I believe the 3 will be better. The face turnout is usually very low because of distance where people have to travel to come and all.
Okay. Yes, so that's why I am preferring the 3, but you have decided that you have shared yourself into 5. Because I remember my first option was 3. And then someone even mentioned that you were 20 in some group. And I said, no, 20 in a group cannot help us in this area. 10, no. 7, no. 5 is maximum. That's what I said. And you have decided to go for the maximum. So, again, I'll leave it for you.
Yeah, so I wanted to ask Baja, if we are supposed to go by it, how will you know that there are 3, all of them will come? So if for 5 and then if 3 or 4 people come, that one is better than maybe 3 and then only 1 will come or 2 will come.
Yeah.
Okay, so settle on it. So cost rep can connect.
We have a lot of things to learn. What's this group? Let the person. Let the cost rep.
Who is that? Who is that? Why do you think your opinion is better than someone's own? Who is that?
No.
What sort of
opinion? Do you think that one is better than someone's own?
No, but you should not talk. Why would you come in? Why are you shouting on us? Who do you think you are shouting on?
No, we are in class. The lecturer is saying something. Let's listen to what the lecturer is saying. Stop what he has been doing.
And then you are here shouting on us that we should. What's wrong with you? Are you serious?
It's okay. I beg, let the class proceed then.
Please, let's do this one. If you settle on 3, each group will provide 2 sets of cables. If you settle on 5, each group provide 4 sets of cables. So that is the order. So choose agree and settle on it before we meet. So let's proceed with today's lecture.
With the cable, which of the cable do you which of the
we
cut?
are done, I think we will agree what to do.
Or any of the cut is okay.
Oh, Cat6. Nowadays we don't deal with Cat5. At this age. No. Cat6.
Okay, so you want
Cat6. Minimum Cat6. If you want to break Cat7, that's fine. But Cat6 is the standard one that we all need. So you can bring
Okay.
UTP or STP. If you even have SFTP, you can bring, but I will provide, God willing, I'll provide the varieties to show the differences of the cables that we have. But for the purpose of our normal practicals, UTP Cat6 is okay. All right, so let's proceed. So today we'll look at the protocol, the TCP IP addressing that we started. And if you talk of TCP IP addressing, it's simply a way of identifying devices on the network and how individual devices are also identified. But our major concern will be on the IP addressing. Even though we have different, are we safe?
Oh, there's an echo.
Okay. Even though we have different types of addressing, but I'll talk about all of them, but we'll send our main studies will be on the IP addressing. So if you have not written down the objectives, please kindly do that. And then this one, I'll use this to climax the IP addressing and subnetting. So first of all, I would like to go and talk about what TCP IP addressing is, and then later we'll come back, then we'll settle on the IP addressing. Is somebody having two devices work or having the mic on? You can control that for us. Okay, so when you come to data communication and networking, there are different types of addresses that we talk about. The last time, I think I mentioned them briefly. These four basic addresses are available in our data communication and networking. Can you all see my screen?
Yes, sir.
Yes, sir.
Okay,
Yes, please.
I'm having a light out, so let me run so that my battery can sustain it throughout the period. So we have four types of addresses. We said the TCP IP protocol suited involve four different kinds of addressing. Now, the first one is physical address. And the second one, we have logical address. The third, port address. And the last one, which is the fourth, is specific address. Now, what are these addresses about? In the simple terms, when you talk of addressing, and we are referring to a unique way of identifying devices and networks in the data communication and network industry. So the addressing involve physical identification, logical identification, service identification, and sessions identifications. So we'll take them one after another, and I'll briefly explain them. Then later, I will break them into details. Now, I think the last time we came, those of you who were there physically, I remember mentioning that physical address can also be referred to as what? Physical address. How can we refer physical address to?
MAC address.
Another name for physical address.
MAC address.
Name. MAC address. Good. Thank you. So when you talk of physical address, you can refer to it as what? MAC address. And this MAC address is unique because MAC addresses are addresses that are used to identify various devices that we use in data communication and network environment. So all of you here, your various devices that you have, remember the first thing that we discussed, the component of data communication and network system, component of data communication system comprises with the sender, receiver, the transmission media, we have the set of rules and the data to be sent. Now, this components, when you look at them critically, can be classified under software and the hardware. Now, the sender and then the receiver or receiving devices are all hardware, and they work together with the software in order to transmit data. So the physical device here will be the device being used for transmitting, and then the one, either the one used for transmission or the one used for receiving. Now, all of them need to be identified, and the identification that we give to these devices are referred to as the MAC address or physical address. Please, are we together here? So, yes. If you have your device with you, the only way you can a device will be recognized is by its MAC address, and it is directed or well recognized that every device that connects on the network must have a unique identity. If you are using your laptop, you can use the command either ipconfig, or you use the getMAC to get your device identified. So if you go to the command prompt and you type this, those of you who are here, I think I demonstrated it. If you type ipconfig and you enter, you see that the MAC address is there. You have the name, physical address. This place, you can see the connection, the IP, and then where's the MAC address not showing. So if you want to get it here, you press space /all, you enter. If you search through, you come across one of them called physical address. Physical, yes. I hope you can see this one, right? That's the address we are talking about, physical address. This address is divided into two main sections. We have the network and the device ID, and then we also have the manufacturer ID. So if you look at it, it's made up of 48 bits, and the 48 bit is divided into two. So the first part, which is made up of 6 characters, if you divide 48 by 4, you should be having something like this. First division is, if you divide 48 by 2, what will you get? 24, right?
24.
Yes.
Divided by 2, 16, then 8.
24. And then you further divide 24 by 6. What will you get?
8.
24 by 6.
8.
24 by 2, then you get.
No. 24 by 6.
4 by 8. 6. Okay, you get.
You get 4.
4, yes. 4. So that 4 is called nibble, Nible, meaning that, look at this place. There are 6 characters here. Each of these characters are made up of 4 nibbles. That is 0, 1, 4. So this part defines the device. So on my laptop now, the first 6 characters that I've highlighted, this is the address that is used to identify my device. Then when you come to this place, this last 6 characters here, which is also made up of 4 nibbles, is used to identify the manufacturer. So it will happen that you are using Lenovo, and then the series of Lenovo you are using, another person too is also using the same thing. That means that the two of you can have the same manufacturer ID, but different device IDs. So universally, according to ISO, you are no two devices in the world, either from the same vendor, should have the same physical address. So this is what the devices use to communicate on a local area network. When they are on the same network, they use this number to communicate. And this portion is used to identify the manufacturers. So that is the purpose of the physical address. So if your mobile phones, when you go to device, you scroll down to device, and you check the device property, you see the MAC address there. So this is the purpose. So for a MAC address or physical address, its main purpose is to identify the devices and to prevent the device from having the same number or to identify them to specific user. So that is why we have the physical addresses. So that is basically about the physical address. So either you hear the word physical address or MAC address, it's the same. So, and this is used for local area connectivity. When you're on the same network, you use it to communicate using the protocol called ARP or RARP. That's it. Are we fine? So note, it's made up of 48 bits, further divided into two 24-bit. R24 is further divided into 6. When you do that into 6, you have 4 zeros and 1s, which are called nibbles. So you can look at it here. Physical address is like the hardware level. You see, host to host network layer. So that's why it is organized or operates. So that is the address using to identify a hardware device on our network. Then the next address we'll talk about is a logical address. Logical address, which is also known as what? What's another name of logical address?
IP address.
IP address, good. IP address. And this one, when you are looking at it from the OSI model, that means that it operates at layer 3. So at layer 3, we mentioned that there are two things that take place. One, logical addressing, and then two, determination of the best path of packets. So routing and switching take place over there. Not only that, the logical address, the purpose of the logical address is to be able to identify the specific network that you are working on and then the device that is connected to that network. Note, the MAC address only become visible on the local area network. So now for you to be able to move data from one local area network to another network, for inter-network communication to take place, there should be a layer that should forward the data from the local area network to the other network. That's where the routing comes in. So the network layer is responsible for intercommunication with different networks. So for the ability of the device to communicate with a different network, it needs the logical address. For the device to also to communicate with other devices on the network from receiving packet from different network, it also required the logical address. So the logical address here, which is the IP address, is a unique number which is used to identify the device on the network. Please note the difference. The MAC address is used to identify the device itself. Which is used for local area connectivity or communication. But for the logical address, is used to identify the device on the network and also for inter-network communication to take place. So that's the purpose, and that is the IP address. And we have two types of the IP, two versions of the IP address, which we'll be dealing with. We have the IP version 4, and then we have the IP version 6. And with the version 4, is made up of 32 bits. And the 32 bits is further divided into 4 octets. We refer to it as octet, 4 segments. So it's known as 4 octets. And each of the octets is made up of 8 bits. So if you divide 32 by 4, you get 8. And this 8 bits may be made up of zeros and ones, depending on the kind of network you are dealing with. So the portions that is made up of zeros and the portions that is made up of ones determine the class of IP that you are dealing with. So basically, for IP addresses, we have 2 divisions, as the MAC address also have 2. The first part identify the manufacturer, and the second part identify the device. But when you come to the IP address, the network side is being represented with ones, whilst the host on that network is represented by zeros. So please note this, and that's how we are going to use to establish our lesson for today. So that is the purpose of the logical addressing for inter-network communication, and then also for identification of devices on the network. You can also say that for node identification, node, N-O-D-E, node identification. Okay, any question before we proceed? If you read through the slide, you see all the things that I'm talking about being explained over there. Physical address has been identified, and then the brief explanation has been given. Logical address has also been addressed. So the logical addresses are used for universal communication. So that's communicating with different networks. So when you go through, you see. Now, why we said for universal communication is that the data may not move on a local area network only. So I use the word inter-network communication. So the data can move from the local area network. It may pass through a wireless network, and then may also go through a fiber optic network. So irrespective of the mode, there should be a unique way of identifying the device and the packet that is being transmitted. So further, you will notice that there are some information that will be added to the packet or the data before it will move, which is called payload. So while the data move through different network, ISO requires that the source and the destination of the packet or the data must be identified. And it is this IP address that always help us to do that. So one of the things the IP address will do, which I said the other day, is to identify the destination of the packet or the data, and then also know where the packet, the data is also coming from. So always, every data that is being transmitted will have both the source ID and then the destination ID. That is, the source network ID will be known, then the destination IP will also be known, or network will also be known. So the logical addressing take care of this. So inter-network communication is carried out by the IP address. Are we fine?
Yes.
Yes, sir. Yes, sir.
Okay, so for universal communication, IP address help us to do that. So currently, I've already addressed this. Version 4 and version 6 are available for us to use. Good. Now the next one, which we'll talk about, is the ports. But you look at the diagram here. This will help you to understand it well. Physical layer is on the physical, and then logical is on the network level, which is the IP address, and enable the communication to take place, intercommunication to take place. Now, the next address we'll discuss is the port address. Someone may said, why do we talk about port? Is it my port or which one? Or local port in your kitchen? Now, the port address here, you see, it's not enough for the packet or the data should be dropped in the in the destination network or device destination network only. Even though the IP address will determine the destination, maybe the packet is going to from Accra is going to Kumasi, someone at Kumasi, and then it has identified that oh, this is the Kumasi network. So let me drop the packet at the Kumasi network. Or it's going to US. Now the IP determine that okay, I'm from Ghana, I'm moving from GCTU and I'm going to US, maybe a particular university or a particular person. Now, the IP address will determine that destination, a destination's network. So when he gets there, he will deliver the message, the packet, or the data to that particular destination network. But it may not be just that individual device that is connected to that network. There might be different devices. So what will happen? It will deliver the message to the network and to get to the device on that network. But inside that machine, as some of you are listening to me now, some of you may have other applications running on your computers. Some of you might be chatting. Some will have maybe some TikTok. Some will have WhatsApp. Some will have web applications. Some will have PowerPoint application. Or some will be dealing with other type of communication with other people. But here we are using a Zoom chat or Zoom conference software. Meanwhile, you also have WhatsApp, and then someone who is having TikTok. Now, when the packet drop or the data drop in your machine, you are not the only one. You are communicating with another person. So the IP address alone is not enough. There should be another address that will identify the particular application or the particular session where there is a communication supposed to be delivered. So that is where the port address comes in, because even though you have arrived on the network and the device is connected, but there might be other application that is running on that particular system. Even if it's the same application, you might be communicating with a different group of people. So how will you identify this to maintain it? So the port address comes in, depending on the kind of communication. Right now, we are doing video and audio combined. So you see over here, the TCP, the UDP protocols available. We also have SCTP. Those of you who were in class last, I've explained the TCP and the UDP. The TCP is Transmission Control Protocol, and the UDP is User Datagram Protocol. Both help in transmission, but TCP is reliable and the UDP not reliable. UDP is fast because it does not wait for response before it sends packet. TCP ensure that the packet is delivered, bring a feedback before it goes. So to avoid the two, to combine the two, we have the SCTP, and this one helps us to do streaming, and particularly what we are using now is using this. So SCTP, stream control help both multimedia and audio transmission. So now to augment this, the port address will specifically state which type of service or which type of application you are dealing with at that moment. What are you doing specifically? Like in terms of delivering the packet to you, the port address ensure that the address is uniquely identified in order to create a session so that you can have the message delivered to the intended person on the same device. So that is the purpose of the port address. And there are unique numbers, unique addresses that are there to I want to web information that you have may be different from someone doing the streaming. So the protocol that supports streaming is different from the protocol that supports you fetching a web content. So for instance, to fetch a web content, you need the protocol known as HTTP. So that HTTP protocol that you need, which is having port 80 for normal web content or web applications to be able to deliver or to fetch information. The port 80 that you are using to fetch that information from a web page or to transmit something to a particular page is what we are referring to as your port address. If you are also going to do multimedia services, you need a specific port number that will be able to deliver that, and that becomes the port address. So there's a difference between the port address, the IP address, and then the what you call MAC address. And we are going to deal with the specific address also. So look at this. We said for logical addresses, what they do is that for the port address, the main purpose is that it helps you to do what you call process-to-process identification. Process-to-process identification. That's the key difference with the port address. Process-to-process identification. So if you go through the slide, it's saying that logical address facilitates the transmission of data from source to destination device. From source to destination device. After it gets there, that is the end-to-end delivery. But the source and the destination both may be having a multiple processes. That's the multiple processes communicating with each other. So as we are here, transmission is taking place. All of you are connecting to me. All of us are doing the communication. But every one of us is being identified uniquely on the communication. So that's why when you create a Zoom session, it comes with the ID. It also comes with the password. That one help us, all of us, to communicate to one particular session. If you have another group of people also using the Zoom, they also have their ID, even though the same application, but their session will be created differently. That make it unique. So the port addresses simply what it does is that it helps in a process-to-process communication, so that even though you connect to the device, you have to connect to the user or particular session that you want to connect to. And that is the purpose of the port address. It ensures that the message is delivered to a particular device and then also a particular process that is involved in that particular communication. Please, are we together here? Hello?
Yes, sir.
Yes, sir.
Okay. All right, so that is about the port address. So what you have to know is that there are a number of services or processes that will be occurring with different port addresses. So for instance, if you want to have a IP address resolution, there is a service that is responsible for that one called DNS. If you want to issue particular IP address specifically, we have a process that is responsible for that one. So DHCP will have its own number. And then if you want to transfer file from one machine to another using the file transfer protocol, you have its own address. So port address, what they do is that they send message, ensure that it delivered to the internet device with a session that is required. So if you go, you read through, it's also made up of 16-bit address specifically. Then the last address that I want to talk about is specific address. Specific address. Now this is where, if you are not careful, you get confused with the specific address and the port address. Now, let me just make it simple for you to get the difference. Whilst the port address is responsible for process-to-process communication, the specific address is responsible for you getting the different sections on the same process, different sections of the same process. And if there are some programmers here, you get the understanding better. Anytime you connect to a particular web application, a session is created. Session is created for you. And that session comes with a session ID, which will sustain your communication and end. For instance, all of you, we are all connected to the Zoom, and we are having our lecture here online. Yes, though the Zoom comes with its own ID that we all have to connect to and join. Now, intercommunication within this particular process also varies. So once you have connected, there should be a session that is created for you so that you can also be identified on this particular session as we are communicating on the big platform, which is the Zoom. A typical example is those of you who have the MTN Momo. You notice that even though you are connected to MTN network and you go and connect to the Momo application, any transaction that you do, you have a transaction ID, which is different from each other. So if you, in a day, you make 3 or 4 transactions, each of the transactions will come with its own session ID or transaction IDs. That is the specific service or specific address that we are talking about. So even though you connect to the Zoom, the MTN or the Momo app, and you are able to do your transaction, it is possible that you may send to different users. So each of the message or transaction that you do, there should be a way of identifying it. It's not enough just to connect to the Momo application and then just do your transaction. If you don't have that session identity, it will be difficult to track and see the transactions that you have done with the various individuals that you did the transaction with within the day. So each time you send or you receive, especially those of you who have been sending, when you send, you will see the, apart from your reference that you will provide, when the message goes through successfully, you will receive a transaction ID, which is telling you that with this process that you have done, this particular time, this is the ID identifying that your transaction. So that is a typical example of specific address. So that if they are tracing you back or something happened and the message, the money is not delivered, or the recipients could not receive the message as intended, the service providers can trace back and know which of the services that you did that did not go through or went to the wrong person. So that is the purpose of the specific address. Hello? Are we here?
Yes, sir.
Yeah, yes, sir.
Good. So, any concern?
Yes, sir.
Anybody have
We're
challenges?
good. We're good.
Good. If you are not good at it, let me give my number. You try it and see whether it will come or not. Then I can give you the code that you see. So that's a very special way of looking at it. All right, so we can move on, right? So when you are asked to explain these addresses in data communication and network, please, you can do so. So now when you are doing your transaction, please be careful and be conscious about those sessions IDs that you get, and then also the transaction IDs. They are not for fun. They are meant for specific purpose. Thank you very much for understanding these specific addresses that we have talked about. On this note, our lesson will be centered more on the IP address, and we'll talk more about the IP version 4. So that's where we'll center our lesson. The rest of the slide, we'll be discussing the IP address, the type of IP address, the version, how IP address are created, how they are assigned, and IP address. So subnetting comes in. So for me to make it easy for you to understand, I would rather prefer to use the second slide to make the lesson more easy for you to understand another one. So with this, when you come to the IP addressing into details, since we are focusing on the version 4, we have to know the various classes of IP address that are involved, and then how they are identified, and how we can also assign IP address. This is the aspects that I said we'll be doing the configuration. So we have 2 methods of IP address assignment. We have the static way of assigning, which is known as manual, And we also have the dynamic way of assigning IP address, which is known as DHCP. And they are all specific services that are provided or offered. So when you go, you see a number being assigned to this. So this one becomes the example of port address for it to be able to drive to a particular device. So if you ask this question, what is an IP address? Who can tell us what it is? IP address. You're supposed to know what it is, know the types, know the classes. We'll look at the unicast, multicast, and broadcast. About your level, I don't want to bother you so much about the multicast and then the broadcast, but you understand it. I think last time it was Angela also. She asked me a question. I told you there are three. They are here. Unicast, multicast, and broadcast. And who will tell her what IP address is? IP address, not the IP addressing.
Hello, sir.
Yes,
Sir,
go ahead.
IP address is uniquely identified device on the internet. That's on the internet.
Please come again.
IP address identified device on the internet uniquely.
Okay, IP identify device on the internet uniquely. Okay, that's fine. So good. Any other person? Before you go to the internet, you can even break it down.
On a network.
Uniquely, it is a number. So I'll prefer that it is a binary number. Hello? Is somebody on the floor?
Yes.
Hello, can you hear me?
Yeah, we can hear you.
Okay. So if, in a way of defining what IP address is, you can say that it's a unique number or it's a binary number that uniquely identified devices on a network. Now, this network can be your local area. And it's a devices on network, or it's a unique way of identifying device on network. Just as we said, no two devices on this planet, on the earth, should have the same physical address, the same device, the same brand. They shouldn't have the same physical address. In a like manner, no two or more devices on the same network should also have the same IP address. Each device on the same network must have a unique number so that they can easily be identified. Like in this class, all of you have unique IDs. If there is anyone here in this class that your ID is the same as your colleague, then it might be a system error which needs to be rectified immediately. Even though we are coming from different backgrounds joining together, still you have to have different way of identifying you. So that is what the IP address is. Now, when you talk of IP addressing, then we are referring to the process of identifying the various devices on the network. So the addressing becomes a verb form. Now, two ways of IP addressing. As I said earlier, we have the manual way of identifying the devices or addressing them, and then the automatic way of identifying them. So when you are on the normal network, we talk about IP. But when you are on the Apple Talk or Novell network or Internetworks, then we can talk about IPX. IPX. So please note this. Apple's networks, we talk about IPX, or Novell networks, Internetworks, we can also talk about IPX. So that's what you know. Then the versions of IP address has already been addressed. We have version 4 and then version 6. And version 4 is made up of 32-bit, version 6 made up of 128-bit. So those mathematicians, IP address can be represented in two major notations. Two notations. We have what we call binary notation, and then we have what we call dotted notation. So please note this. When you talk about binary notation, then we are referring to the one with zeros and one. Zeros and one. Come again. Hey, are we safe?
Francis. Kibo Gariana.
Are we safe?
We are safe. We are safe.
We are safe.
All right. So look at the notation of IP addresses. Binary notation, and then we have dotted notation. Who can tell us the difference between the two?
Hello, sir.
Hello, sir.
Hello, are we good to go?
Yes, sir.
Tell us the difference.
Hello, sir.
Yes.
Yeah, so with the binary notation, it deals with zeros and ones.
Okay.
Whilst the dotted decimal notation is the normal numbers that we normally use, the counting numbers.
So dotted notation means the decimal. We're dealing with the whole numbers.
Counting number. Yes, counting whole numbers.
Whole numbers. So now, when you have this 0, this 110001, another 10000011. These are the dotted notation. So there are two ways that we can represent our IP addresses. So in your exam, an IP address can be given to you, and then you'll be asked to represent it either from the binary notation to whole numbers, or from whole numbers, or we call it dotted notation, to binary notation. I'm sure you have done mathematics, binary conversions, so you can do that, right?
Yes, sir.
Okay, good. So benefit of IP addressing. So one of the benefits of IP addressing is that you have a flexibility in how you can take a network address and subdivide that address into multiple subnets. And that comes into what we refer to as subnetting. So subnetting is a very interesting area, which I'm sure you love it for us to delve into it. If you are not able to finish it today, I'll find time and complete it in our next meeting. So that's what you must know. So in mathematical expression, converting from one unit to another, you always deal with the number basis, the principle of number basis or binary numbering. That's what we use. So since we have all studied it, I will not worry myself at all. I can just give you an example for us to convert, and then you'll be there. Assuming face to face, that will be fine. But with time, I can also write for you to see. So if you are asked to do the binary conversion, please, what we need to know is that there is a number that the way I will go about it. You only have to take the base 2, the binary system. You all know that binary system, we convert from this 0 and 1 to whole numbers. So for instance, if you have something like 192 and then 168. Can you see my screen?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Good.
Yes, sir.
No, 20. If you are asked to, this is dotted notation. If you are asked to convert this one to binary notation, all that you need to do is that, the IP address has 8 octets. So as I said, sorry, 4 octets. Each octet is divided, it's having zeros and ones, so 8 of them, the bits. So each of the octets have 1, 2, 3, 4, 5, 6, 7, 8. So if you are to, so this octet here, it represents this one, the first one. And the second one, it also represents this one. And the third represents this. Please, are you following me? This is the fourth one.
Yes, sir.
So the first one, if you are to convert it, you only have to do this. 1, 2, 3, 4, 5, 6, 7, 8. There's the bit over here that I brought outside. Then you go by your normal binary conventional way. 2, 2, 2, 2, 2, 2. Then you raise it to the power from 0 to 7. So 0, but you make sure you start from right to left. So 1, 2, 3, 4, 5, 6, 7. Please, are we together here?
Yes, sir.
Yes, sir. We're good. We're good.
Yes, sir.
So should I jump over or I should proceed?
Sir, I'm
Proceed,
lost.
proceed,
Could
proceed,
you
proceed.
kindly take it once more, please? I'm lost.
Come again.
Please, I'm lost. Could you take it once more, please?
Okay, I said the 32-bit IP version 4, it comes with 32 bits like this. So the whole of this is 32 bits. And then each of the 32 bit, the 32 bit is divided into 4 octets. And each of the octet is made up of 8 bits. So when you write something like this, on the normal dotted notation, and you are asked to convert it to binary notation, you should know that the first one is represent the first octet, second one represent the second octet, and then the third one, third octet, and then the last one. So normally, depending on the class of IP address, that will determine side that belong to the network and the host. But for now, we want to now see how we can convert this to binary 192. So I'm saying that in order to convert to binary, you pick one of the octets, the ones over here. So there are 8. So you just write 1, 2, 3, 4, 5, 6, 7, 8. Remember. Then you now raise these ones to the power of 2. The way we do the normal mathematical conversion in binary. All of them are raised to the power 2. Then after you are done with this, what you do next is that you raise these 2's to the power of 8 bits. But here you start from 0 to 7. So we start from right to left. So 0, 1, 2, 3, 4, 5, 6, 7. Are you fine now?
Yes, sir. I'm following.
Okay, so now to convert this to dotted notation, what you do is to just pick them like this as 1, then you add to this one. So the first one is going to be 1 to the power of 2, 1 times 2 to the power of 7. So this you add. Then this one, 1 times 2 to the power of 6. Then you add again. Then 1 times 2 to the power 5. And to the end. Please, are you all following?
Yes, sir.
1 times
Yes.
2 to the power of 4. And then plus 1 times 2 to the power of 3. Then plus 1 times 2 to the power of 2. Then plus, you continue, 1 times 2 to the power of 1. And plus 1 times 2 to the power of 0. Okay. So if this, then what to do? Come back. 1 times 2 to the power 7. What will be the answer?
124. 128, sorry. 128.
So thank you. 128. Then, oh no. We are finished with the 7 is 128. Let's add.
Yes, sir. It's 128.
Hello?
And yes, it's 128. And then the
Next one.
64.
2 to the power 6.
64.
So 64. Thank you. Hey, the rest, are you here?
Yes, sir.
Yes, sir. Yes, sir.
Then 2 to the power 5.
32.
Thank you. Then 2 to the power 4 times 1.
16.
16 plus 2 to the power 3.
8.
8. Thank you. Plus 2 to the power 2. 4.
4.
Plus 2 to the power 1.
2.
2.
Now 2 to the power 0.
1.
1. Thank you. So now that you have done this, then you add all. So mathematician.
255.
All
255.
of them, right?
Yes, sir.
We have all of them. This one all go to the power to be 255. Okay, good. So that is telling you the full octet here. That's the full size. If you go to the next one, you add, you get the same thing. So now, we are now having 192. So how do you convert this one? 192. No, this one is in the binary that we have converted to get 255 as a full block. So what we need to know, this one must be in your head. Always when you see something like this, 1, 2, 3, 4, 5, 6, 7, 8. You should know that the full block will give you 255. Oh, sorry. Let me write it well. The full block is 255. So what you do here, if you are having 19192, it's in the dotted notation, and you have to convert it to binary notation, then you have to do the reverse of what you have done. Are we fine? You do the reverse.
Yes, sir.
So, to do the reverse of this, there's a simple way of doing it. And the easiest one that you can go as a traditional mathematician, you can have this 192. Then 2 to the 2 into 192. What do you get? 2
90.
into 192.
96.
96.
Thank you. 96. Then remember what?
0.
Remember 0. Okay. Then 2 into this. 96.
48.
So 4, 8. Remember
0.
Then 2 into 48.
24.
24. Then remember
0.
0, right? Yes. Then 2 into 24.
12.
12. Then remember
0.
0. 2 into 12.
6.
Remember 0. 2 into 6.
There.
3.
Remember
0.
0, right? Then 2 into 3.
1.
Remember
A
what?
1. Remember 1.
1.
1.
Okay, so yeah, it's 1 remainder 1. Then 2 is to 1.
0 remainder 1.
So 0. Thank you, remainder 1. So now, if you are going to find it, you take from the down up.
Yeah.
So that. So it's 1,
1.
2, 3, 4, 5, 6, 7, 8. So this one is going to give you 1, 1, 0, 0, 0, 0, 0. So how many zeros? 6, right?
6 zeros.
So another one. So then it become dots. Then you come down. The next one is 168. 168. If you have to do it the same thing, you come and do this. 168. Then 2 is to this. I hope you can all do this, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Good. So you do that one too, then you get your answer. So that is how you convert from dotted notation to binary, or from binary to dotted notation. There's a simple way that you can do it, and then you can be fast with it. So let me show you that one too, then we'll move on. Anybody with a concern or trouble? Let's see, I can get a new page.
Yes, sir.
Yes.
Sir, please, why did you multiply the 1 by the 2 with the exponent? What is the significance of that one to the conversion?
Hey, did we multiply? Why?
So the first answer that we got, the 255. I'm asking
255.
what effect does it have on the conversion?
Oh, yes. That is the principles of how to convert from binary to the whole numbers. The basic principles, which you must know. And I don't know if all of you know, as you are asking. So it's the principles of conversion of binary to whole number. And then from whole number to binary, there's a reverse. That's what I want to show you.
Okay. Thank you.
All right. Because with time, I may not be doing this. As you grow, I'll tell you, if you have something like this. Oh, okay. Let's see. A time will come, you have something like this. 1, 1, 0, 0, 1, 1, 0. 1, 2, 3, 4. Yes, I can ask you to convert this one to this binary, right? You agree this one is binary? Yes.
Yes.
There's a way you can convert this one to a whole number. So if you have to do this conversion, you can still go by putting 2, 2, 2 over here. Are you here?
Yes.
So in this case, let's go to 0, 1, 2, 3, 4, 5, 6, 7. So straightforward, if you know what you have done the first time, you know here is going to be 1, 2, 8 plus this one will give us 64. This one is 0, 0. This one will give us 8. This one will give us plus 4. This one will give us 0, 0. So your answer here is going to, who can help me? 64 plus 128 plus 8 plus 4.
204.
204.
Yeah, 204.
Okay, verified. Thank you. So the one who asked the question, have you seen how we arrive over here? Hello? Are we safe? Are we good?
Sir, we are good to go.
Thank you. So I brought this part in order to explain future things so that when you go into future work, you don't get confused. All right, so let's take this. Another simple one. Assuming that you are given the 192 and then 168.10.20 that are written first. If you want to use a shortcut to convert it, you can easily draw a line this way. And then you know that you have these numbers written already. So you have 128, you have 64, 32, 32, here will be 16, right? You have 8, you have 4,
4,
you have
2,
2,
1.
And then 1.
1.
So 1, 2, 3, 4, 5, 6, 7, 8. Good. Then you have 192 here. And then here will become 168. You can do it very easy. There is 10. And then this place is 20. So if you want to use the easiest way of converting it, as you can see, now you decide how many times does 120 goes into 192. Please, the mathematician, fast. My battery is going down.
1.
1. Good. Then you now write 192 minus 128. Please remember, what will be the difference?
64.
64. Thank you. So 64 into 64.
1.
1.
1.
Remember 0.
So the rest will be what?
0.
0, 0, 0, 0, 0. Have you seen that?
Yes, sir.
Yes, sir.
So it's the same as what we had the first time. Then, if you want to also do this, how many times does 128 goes into 64?
1.
1.
No.
Good. Then you come 168 minus 64.
40.
So you have 40. Good, thank you. So 64 into 40, can you go?
No.
0.
No.
So 0. Then now 32. Subtract 32 from 40. When you come here, can 32 go into 40?
8. 1. 1 remainder 8. 1.
So the
1
remainder
remember 8.
8. Good. Then now when you come here, 16, can it go into 8?
No.
No.
Hey, 8 can go into 8.
Yes,
1.
sir.
1.
1.
But
So remember 0. So 8 into 8, 1. Remember what?
0.
0. So 0, 0, 0. Can we see that?
Yes, sir.
Yes, sir.
Good. Now, if you want to continue, this is the easiest way. Can 128 go into 10? No. 64, can it go into 10?
No.
32, can it go?
No.
Okay. Thank you. Then 16, can it
0.
go?
No.
0.
So all of them, you just put 0, 0, 0, 0 there till you get to where it's possible. So 0, 0. Hey. Oh. My mind is in. So yeah, yes.
Your thing is not friendly with you.
It's giving me tough time. Then 8 into 10.
Into 1.
0.
Remember 2, right?
Yes, sir.
So 4 into 2, 0. 2 into 2, 1.
1.
And here,
0.
So that's how we do the conversion. Then the rest, you can repeat the same thing. 0, 0, 0, 1. That will be 4. 0. My friend, you have to make my life easy for me. 0. So 4 into 4, 1. So 0, 0. So that's it. So if it comes in the examination, you are asked to represent this one in a binary notation. You can choose to go by the tabular format, or you can decide to go the long division. You take this one first, you solve it, you move on to this, you solve, and you move on to this, and you solve. So I just want you to understand the dynamics of the conversions from decimal to whole numbers, and then from whole numbers to decimal. Sorry, from decimal to binary, and from binary to the whole numbers. Are you okay?
Yes, sir.
Yes, sir.
Yes, sir. We're good.
Good to go. I have a number of people online, but only few voices are coming. I believe the rest are all with us. The Lord help you.
We're good,
Yes,
we're good,
sir.
we're good. Amen.
Thank God.
We're good.
Hello, sir.
Yes.
Yeah, so this is Justice.
Yes.
This is I wanted to
Yes,
find out.
Zain, go ahead.
Okay.
Any cause for alarm?
Okay, so I wanted to find out, aside these two options that we have given, as to how we can use to convert to other the binary to decimal and decimal to binary. If we have other means to, can we also go by that method?
Which one is that?
No, like I'm just asking.
He's
Because maybe some of
asking.
us, yes, some of us may have a different method of going by it.
For inversion.
Then teach us. Teach us.
Justice. You see, there are some ways. It's shortcut are dangerous. Well, there
Yeah,
are
you have
two.
But I
yes.
I think what he means is he has a different way of tackling
Method.
it.
That's what I'm asking, which one is that? So you should let us know what it is. Then we all analyze it, so we can also learn.
Oh, like it's the same principle. Like just that with the table one, the 1, 2 is 64, 32 up all the way up to 1. Just that maybe from experience we'll be able to do it faster than we did over here. That's what I'm asking.
No, listen. You have to follow the principles. When you are dealing with professional exams in terms of objectives, that one you can use your short way or ways and means to get the answer. But if you are to do in examination, you have to provide a solution. You must outline the procedures. So you may either choose the first method, the long division, or you go with the tabular format to express your table to show how you arrive at the point, but not just to do ways and means and put the answers there. Otherwise, there will be no proof.
Yeah, that's why I wanted to get clarification on that. If
I
we
will
could
prepare
use
that
other
to
means
show
to
the
get,
method.
yes.
Whatever way you want to use, show the method. Logically, we all follow
Okay.
it and see how you have arrived at your answers.
Sure. Thank you.
Okay. So, my people, go down, go to the slide, and then you'll be fine with this. I've explained all this portion, so I need not to read the slide to you. All of you can read and read faster than I do. So let's move on. So converting decimals to numbers, to binary numbers, please go and sit down if you have any problem. If you have, ask now. If not, then we can follow the procedure. So examples are given in the slide. Now, the next thing that we'll be doing, now that we are finished with the conversion, this is very important too. You'll be applying it when we come to the subnetting. You have to know how to convert. Good. Like this. Justice, where are you? Open your eyes properly. Like here, if you use the objective answers like this is a personal exercise which I want you to complete. If you are asked to provide the answers for this solution, if it's objective, you can decide to just provide the answers there. But if it is not in this format and you are asked to give us the workout, then you need to work out how you arrive at the answers.
Very well noted, sir.
So please try your hands on this yourself. So the rest, I'll leave it for you. And this is a tabular format, how you go about it. So if you are going by the table, make sure you put the conversion there to explain, to establish your point. Okay, now the IP version 4 structure, let's look at it quickly. Now the IP version 4 structure determines the various classes of IPs that we have. We have 4 major IP addresses. Let me put it that way. Class A, B, C, D, E. And the 5th one, which is for reserve. So those of you who are still studying, you can come out with a structure and then move on. So look at this. We represented the IP address in a binary notation and a dotted notation. I've tackled it. Then the next one I will talk about, if I don't do this, some people will think that I've not taught the lesson. So please permit me to show them. Okay, now, what is subnet mask? How will you define what a subnet mask is before we go to the IP address structures and the classes? You have 10 minutes to go. What is subnet mask? Yes.
The simple means it dividing one big network into smaller networks.
No, please, not what is a subnetting.
Hello,
Subnet
sir.
mask.
Hello, sir. Hello.
Yes, go ahead.
Yes, so with the subnet mask, it's one component of the address, and that determines the network address and the host address.
Okay, good. When it comes to subnet mask, we say that it's a binary digit that determines which part of the IP address belongs to the network and which part belongs to the host. So basically, every IP address, our IP address version 4, the structure is like this. The structure, when you are drawing it, it goes this way, which you have the octet divided. And know that this portion, the whole thing is 32-bit. Now, and this one, they are supposed to be made up of zeros and ones. But it's not always that all the block will be full of ones or the block will be full of zeros. So always every IP address comes with 2 main portions. We have the network ID or net ID, and we have the host ID. Always the net ID represented with ones and the host ID with zeros. So the portions that is represented with zeros always is known as the host session, and then the ones represented with ones is a network session or the network ID. So when you come to the binary, sorry, the subnet mask, it is the zeros and ones that we have, and the portion that shows the network side and the portion that shows the how do you call it, the host side. So it comes to the classes of IP address, the version 4, we have primarily 5 classes that we can talk about. We have the class A, which is also known as /8. We have class B, also known as /16. We have class C, also known as /24. We have the class D, also known as multicast. And then class E, which is, you can call it either reserve or research. Class E, which is a reserve or for research. So this is the many classes that we have. Are we fine? Okay. When you come to the class A, the class A come with the division like this. 1, 2, 3. And only the first octet is filled with ones. 1, 2, 3, 4, 5, 6, 7, 8. And the rest are 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and then 0, 0, 0, 0, 0. So means that class A, this part is the net ID, and the whole of this is the host. Are you fine?
Yes, sir.
Hello?
We're good,
Good.
we're good, sir. We're
And
good.
there's a way that you do the calculation. If you want to determine the number of hosts, it's always, this formula should not be far away from you. It should always be in your head. So this, now, the n here is representing the number of zeros. And then the 2 here, we have 1 to be the net ID, and the other one is ID. So then you have to use this formula. So over here, we have a rule that says that the first highest bit is not used. So to determine number of hosts, your n here equal to 7. N on this place, n is equal to 7. So you have h equal to 2 to the power 7 minus 2. So those who calculators, please give me the results.
126.
1. Sorry. The host 0, 0, please, zeros. The 0, 8 plus 8 plus 8. How many?
32.
32. So please, sorry, this one is not the. I'm doing the networking. So this one, I was doing the networking part. This part is, yeah. No, 8 plus 8 plus 8.
No.
24.
24, yes.
To give you 24 bits, right?
Yes, sir.
So you come here, this one go to the power 24. So please kindly do the calculation for me. 2 to the power 24 minus 2. Yes, 24.
2 to the power 24.
Minus 2. You have 1, 6, 7,
7,
7,
7, 7.
7. 1677, please.
214.
Let's hurry up. 214.
Yeah.
Have you subtracted the 1 already? The 2 already?
Yes.
Okay, good. Now, when you want to determine the network, network is known as capital N. Is a network, the formula is N equal to 2 to the power X, where X equal to 8 minus 1. So this place, one of the highest bits will not be used. So you have 2 to the power 7. Then this one will give you 1 to 6. It's 1 to 8. 1 to 8. So that is the total number of network for class A. Are we fine?
We are good.
Okay. Then the next one is class B. If you are drawing the structure for class B, it's going to be like this. 1, 2, 3. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this, the rest 0, 0, 0, 0, 0. 0, 0, 0, 0. So here, this part is your net. Is my friend. My friend want to delay me. The network. Are some people trying to capture my screen? We have network, net ID, and then from here to this place is the host ID. So here, if you are calculating the number of hosts, you have 2 to the power n minus 2, where n now is equal to 16. Are we good? 8 plus 8, 16. So you calculate it 2 to the power 16 minus 2. Anyone with calculator. Then when you come to the network, we have n equal to 2 to the power x, where x equal to 16 minus 2. Yeah, it's 2 to the power 16.
65536.
65536. Have you subtracted 2?
No.
34.
And please. So if you subtract minus 2, you have 65534. This is the number of hosts. And then when you come to the network, the first 2 highest bits are not used. So we don't use the first 2 highest bits. That's why you subtract minus 2. So we have 2 to the power 14. So, yes, anybody?
To the power 15.
14.
Why 15?
14.
The first highest 2 bits, the first 2 highest bits are not used.
Yeah.
So say it's 16,000. It's 16384.
16384. 384. Thank you. So this is number of network that you can get from class B. Then the last one, I want you to do it and tell me before you go.
Please, our time is almost up, so if we can move on.
Yes, I'm saying that do the third one for me before you go.
That is class C. How can you?
This man want to run away. Class C. If you come to the class C will give you class C. Why? Because of course repo, it make my screen is not work anyway.
So that thing want you to stop.
24.
But we have to finish it.
Okay.
Okay, so class C, if you draw the structure, who has finished? We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3.
So this is
Yes.
24.
Number of the networks.
24.
Yes.
Minus 2.
2097150.
Okay. Network. Oh. Some people are fighting against my thing.
And the subnetting is 16.
Okay, so host equal to 2 to the power n minus 2.
Yes,
and then network, we have n equal to 2 to the power x, where x equal to how many?
3.
Yeah, so we have 24 minus 3.
Minus 3, 21.
21. So 2 to the power 21. And then here, what's the number of zeros? 8.
8.
We have 2 to the power 8 minus 2. So this will give you 256 minus 2, 254. And network, who have the correct answer?
209.
209.
7150.
7152.
Minus 2.
209.
7152 minus 2.
52. Like this.
So it's 2,097,152.
Okay, yes. Yeah, we don't subtract. So we measure as it is. So that is it. So this is the number of hosts that you, number of network, and number of hosts. So you realize that most of our routers that we use, most of them are class C. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now look at this. Where you have the one, all the ones, what will be the conversion of this? When you convert all this one, what will be the value?
255.
255.
We have 255. Yeah,
255.
255. 255.
255.
And here will be what?
0.
Good. So this is your subnet max. So we define a subnet max that it is a binary digit that determines which portion of the IP address is network and which portion represents the host. So you can see clearly here, this is the network side, and then this side is the host. Are you all fine?
Yes, please.
Good.
Good. Thank you for coming. I'm sorry that our time.
Sir, my marks, though. Sir, my marks.
Which of the marks? Okay, today I'll be very active. So I think that record yourself, keep 1 mark for your active participation in the class.
Wow.
So,
thank you.
Yes, I've taken you through this calculation, network address calculation. We have done it. So please go and read. What we'll be doing next time will be about the subnetting. I have not been able to touch on the subnetting today. It's a very interesting part, but because of time, we have to end it here. So I'll encourage you to read through. This is what we just did. The IP address classes, the various ranges where they start from. Class A start from 1 to 126. Class B start from 128 to 191. Class C 192 to 223. And then class D 224 to 239. And then class E 240 to 225. Please note this and keep them. You can see the corresponding subnet marks, and you have seen where they are coming from. /8, /16, /24. I think I'll be able to take you through all this. So on this note, I would like to end here and find out if there are questions from any of you before we end. If no question, then we'll end here today. What I would like you to do for me, go and read my message of the day. Luke chapter 5, verse 5. That's what you should read. And then next time we meet, we'll discuss it in the Easter festivity. Are we meeting next week?
No, sir.
No.
No.
Hey, why no?
According to the timetable, no class.
Easter break.
Okay. So those of you who are going to celebrate, please enjoy with care. And then remember the purpose of the season. It is all about Jesus. So make sure you witness to someone what Christ has done for all of us. And God will bless you. So please, on this note, we'll end here. Next time we meet, read through, and then we'll talk about subnetting. The only thing I didn't talk about, private IP address and then the public IP address. When we meet, somebody remind me. I'll take care of it before we continue. Thank you for coming. I hope you have followed the lesson up to this point.
Yes,
Take
please.
care of yourself and stay safe. See you, God willing, next week for next 2 weeks for subnetting. Bye-bye for now.
Bye-bye.
Okay.
Bye.
Take care.